So Viman, it's for you. I'm trying to make you understand about Sawhorse and Newman projection formula. So first I will go for Sawhorse projection formula. It is actually provides a graphic 3D perspective picture to specify the conformation, and it shows also the relationship between the substituents that are linked with the carbon. Here, if we take an example CH3 and CH3, so it is our ethane CH3 bond CH3. How can we represent this structure in Sawhorse projection formula? So here first of all the bond between two carbon, so it is our main bond. So we need to represent the Sawhorse projection formula at least two carbons, right? So the bond between these two carbon atom is drawn diagonally and slightly elongated. So here it is our first carbon, this carbon, and the second carbon is this one. So 2 end determines the two carbon, right? So the other bonds, these other bonds are represented by small solid lines. So here the 3 hydrogens will be linked by 3 small bonds. Same, these 3 hydrogens linked with the second carbon will be drawn as like that. The 3 groups attached to one carbon we will draw is like, and the second carbon in this way. And there is a free rotation about the carbon-carbon bond. As this is the single bond, carbon-carbon linkage, carbon-carbon single bond. So here is possible a rotation. So free rotation is possible along the carbon-carbon single bond. And the 3 groups, here we have taken the 3 groups are 3 hydrogens. Here also the 3 groups attached to carbon are hydrogens. So free rotation about the carbon-carbon bond is possible, and the 3 groups attached to one carbon, maybe this carbon or this carbon. So the 3 groups attached to one carbon may be rotated clockwise or anti-clockwise. So it may be clockwise or it may be anti-clockwise with respect to the 3 groups attached to other carbon, right? So the rotation may be clockwise or anti-clockwise, and it will depend on the 3 groups attached to other carbon. So rotation of this will vary with the position of this 3 groups of another carbon. So here it is our front carbon, this one is our back carbon, and this type of conformation is called as eclipsed conformation. Eclipsed conformation, right? So again another conformation is possible, not another, actually infinite number of conformations are possible. And another conformation like that, it is eclipsed. Another one will be called as staggered conformation. So one I have drawn as eclipsed conformation, eclipsed, and other one I will draw as staggered conformation. Here I will draw this carbon first. This carbon first I will draw. This carbon. It will be same as I have drawn over here. Same. Again elongated carbon-carbon single bond. This one was back carbon. But here what we will do, I will rotate this either clockwise or anti-clockwise so that keep intact the groups linked with the front carbon. So it is same as I have drawn here, same. But the second carbon after the rotation. So if I want to take this hydrogen at lower position, take this hydrogen and bring it at lower position. So what will be like that? This hydrogen will come downwards. This hydrogen will be back left hand side and this one will be at our right hand side. So this hydrogen number 1 will be come down forward. Number 1, it is our number 2, it is our number 3 hydrogen. So if I bring it at downward side, hold it and keep it downward, then this number 3 hydrogen will be left hand side, number 3 hydrogen, and this 2 hydrogen will be at right. Clear? So this is our staggered and these are our eclipsed. So in case of eclipse conformation, the groups attached to carbon are nearest. That means these 2 hydrogen are at the same side. These 2 hydrogen are at the same side and nearest, and of course these 2 hydrogens also are at nearest. So this is called as eclipse conformation. That means side by side, backwise. These two and these 2 hydrogens are at the just backward side, side by side, and it is the nearest position. So energy will be highest for eclipsed conformation. But in case of staggered conformation, the groups oriented, that means the groups linked with first carbon and the groups linked with the second carbon, front carbon and back carbon, are oriented as far away from each other. So this hydrogen and this hydrogen are far from each other. This hydrogen and this hydrogen is far away. This hydrogen and this hydrogen are also as far away as possible from each other. So energy for this staggered conformation is minimum. So one projection can be transformed into another by rotation one of the key carbon atom. So if we keep intact any one carbon and rotate another carbon by rotation through the single bond, either clockwise or anti-clockwise, we can transform into another projection formula. So among infinite number of formulas, conformations, these 2 are very important because of the energy. This is highest energy system and the staggered is our minimum energy system. So take another example, and one thing, if we change the conformation, transform into one another, but the configuration does not change, right? So take another example in butane, which is CH3 bond CH2 bond CH2 bond CH3. So what are the key carbons? These 2 are key carbons. So we can divide it in 2 halves. So front carbon containing 1, 2, 2 hydrogens, right? Front carbon will containing 2 hydrogens. We can draw it another way. We can keep hydrogen over here. We can keep CH3 over there. But I have drawn it like that. So 2 hydrogens are drawn. Now 1 CH3. So 1 CH3 I have drawn. Single bond. And again this back carbon. This carbon will be containing again 2 hydrogens and 1 CH3. So if I draw it in staggered conformation, it will be like that. So 1 CH3 and 2 hydrogens. Why is it staggered? Because the position of the groups are as far away as possible. So farthest distance. Here this hydrogen and this hydrogen again farthest, and this hydrogen distance is farthest away. So it is called as staggered conformation and minimum energy. No problem if you draw it in here hydrogen, here CH3, it may be. So by rotation you can predict what will be the position of these groups in the conformation. So there is no any problem. It is the actually anti-conformation because these groups are farthest away, possible highest far away. So it is the minimum energy conformation. So it is actually anti-conformation. And another is we can transform it into eclipse conformation. So again keep this portion intact. Again that elongated carbon-carbon single bond. Here what will we do? As we are drawing the eclipse, so the position of the groups will be closest as possible. So this CH3 I have to bring it here, just close to this CH3. So hold this CH3 and keep it here by rotation. So if I bring this CH3 over here, so this hydrogen will be this position and this hydrogen will be at this position, right? So hold this CH3, bring it over here just beside this CH3. So the corresponding hydrogen will be at this position. See now, the CH3 and CH3 groups are nearest to each other. This hydrogen with this hydrogen and these two hydrogen are also nearest to each other. So it is called as eclipsed conformation, and all these are Sawhorse conformation. So here is a total system, total drawings we have done, right? So all these about Sawhorse, in which way we can draw. Next is our Newman projection formula. The way to represent a conformation, the molecules are viewed along the bond joining the key carbon atom. So again, if we take the same example, ethane. So we have to find out the key carbon atom. These are our two key carbons. And the front carbon. So suppose it is a front carbon. The front carbon is represented by a central point, right? Attached to 3 bonds. What are the 3 bonds? These are the 3 bonds linked with hydrogen. So 1 hydrogen, 2 hydrogen and the 3rd hydrogen. So this front carbon is done over here. It's completed. The back carbon is presented by a circle. This back carbon is presented by a circle. Again, 3 bonds are linked over there. So these 3 bonds like one hydrogen, this hydrogen, second hydrogen, and the third hydrogen. So first front carbon is attached with 3 groups. So this front carbon is attached with 1 hydrogen, 2 hydrogen and 3 hydrogen. The back carbon is presented by a bigger circle. And again this bigger circle is linked, that means this carbon is linked with 3 hydrogen. So 1 hydrogen, 2 hydrogen and the 3 hydrogens. Right? So this is our front carbon and the bigger one is our back carbon. It is eclipsed as again the position of the groups are closest, nearest. So it is eclipsed. Again, if we want to draw it in staggered conformation, what we have to do? Again, keep this carbon, front carbon intact. No need to change the position of the groups, position of the bonds. The back carbon is the bigger circle. Now we need to again rotate the bigger circle. So if we rotate it by certain angle, you can see that this hydrogen will become to this position, this hydrogen will become this position, this hydrogen will become at this position. So we actually do it at 120-degree rotation. So one more position, possible position of the groups attached to the bigger circle. This hydrogen and this hydrogen will be maybe in this position. So here the groups, the hydrogens are as far away from each other. So this structure is called as staggered conformation. And think that the single bond, actually we cannot see that C bond C. We cannot see as we are seeing from this position, right? So front position we are looking. So here the single bond, this carbon and the back carbon, front or back carbon, it's linked but we cannot see from the front side. So it is our eclipsed and it's our staggered conformation. One more example I am showing. Suppose CH3Cl8 linked with back carbon like that. So you can start. So it is a front carbon, this is our back carbon which is linked with like that. So it is our Sawhorse. We need to convert it in our Newman projection formula. So front carbon is by dot. This one is a front carbon. So designate the groups linked with this one. So these are same. Back carbon will be bigger circle, this carbon. So we can see the bonds attached to the back carbon. So here it is hydrogen, same position, bromine, this position, and the CH3 at this position. Right? So it is our staggered because this CH3 are as far away as possible to each other. Right? Again that Cl and bromine are farthest away, at least 180 degree. 180 degree. 180 degree. So these are far away. As far away possible, these positions are linked over there. So this is staggered. And if we want to draw it in Newman, then keep it at the same position, front carbon here, right? So now what to do? If we want to draw it at fully eclipsed, then what we need to do? We will bring this CH3 group just behind this CH3. So take it and position it here. So this is our back carbon and the CH3 I have brought it here just behind the CH3. So new position of the CH3 will be here, right? And the bromine will be just beside the Cl. This bromine will be, as this CH3 will become over here, so that bromine will be coming over here beside the Cl. And the hydrogen will be behind the hydrogen. So it will be our eclipsed conformation, right? So little bit about Sawhorse and Newman. I think it may help you, but you need to do some more examples, more transformation that must help you for your further study. So all this about it. If any problem in transferring the system, please make me inform. I will try again for you.